That's our video for Unit 5, Day 3. So we're still working with solving systems of linear equations. So what we've done so far is we learned to solve system equations by graphing and finding the points of intersection. And also solving algebraically by substitution. Today we're going to learn to solve by what's called elimination, right, which is sometimes also called linear combinations. In your other class you might have learned it this way. When we're using elimination, we're only going to be using two operations in the process. We're using multiplication or using addition. So what we're going to try and do is we're going to multiply one equation. This is the big idea here. We're going to multiply one equation by some number that will allow us to eliminate a variable when we add the two together. So that's why it's called elimination. So we're going to multiply by an equation, or multiply an equation by some number that gives us the opposite number of a specific variable in each problem. And then that'll eliminate a variable when we add the two together. Alright, so this is very similar to what we did in the lead-in activity, where we looked at the same number of each variable, and then we could tell that the difference in the end value was the difference of the other variable. That's what we're doing. That's what this whole process is try to eliminate one variable and work one variable at a time solving. So here's an example. 2x plus 3y is 18, 5x plus y is 19. Alright, so our first step is going to be multiply. So I want to multiply so that one equation has the same number of either x's or y's as the other equation. Alright, what we want to do is multiply by a negative. That'll allow us to add, which is an easier operation, instead of subtracting. Alright, so I'm going to do is try to identify where I can multiply one equation up to another equation having the same number. So what I look at here is I see that I have positive 3y in the top equation and positive 1y in the bottom equation. Alright, so I know if I multiply this bottom equation by 3, they would have the same number of y's. Alright, so what I'm going to do to make it eliminate is I'm going to multiply it by negative 3, so they have the opposite number of y's. So I multiply by negative 3, my top equation will stay the same. Nothing's going to change with that one. The second one, we're multiplying by negative 3, so I have negative 15x minus 3y equals negative, multiply 3 by 19, be 57. So once we have it set up that way, we add the two equations together. Alright, and if you've done this correctly, one variable should be eliminated. So if you still have x and y after this step, go back and check your work if something's wrong. So we add these together, we see that positive 3y, negative 3y cancel out. This leaves me with negative 13x. And on the other side leaves me with negative 39. Step 3 is now we look at that equation. That's something we can solve. Negative 13x equals negative 39. So now we're just going to solve this for x by dividing by negative 13. Remember, negative divided by negative is positive. We get x is 3. Remember that we still have to find y, so we go back, we plug this into whichever equation is easier. It might be the top equation has smaller numbers. Maybe we want to use the bottom equation because y is by itself, whichever one. We'll use the bottom equation for this one. So 5 times 3 plus y equals 19. That'd be 15 plus y equals 19. So y would have to be 4. And Remember that we always write our answers to these as ordered pairs. So I'm going to write it as 3, comma 4. So that's how elimination works. So sometimes you might have to multiply more than one equation. You might multiply both equations to get the setup that you want, or one variable is going to be eliminated. So we'll show you what that looks like on this next one. So we'll do the one on the right hand side first. Let's say this time, instead of eliminating the y's like I did before, let's say I want to eliminate the x's. Alright, so on this one, 2 doesn't multiply up to 3, 3 doesn't multiply up to 2, so I would have to multiply both equations. Alright, so understanding the idea of least common multiples or common denominators like we've been working with is very important for this. It can make your work easier, but you can do it either way if you just prefer to eliminate a certain variable. So if I multiply the top equation by 3, I'll have 6x plus 3y is 33. Alright. Now to cancel it out, I would need a negative 6x here that they would cancel out when I add. So that tells me I'm going to have to multiply the bottom equation by negative 2. Alright, so kind of think ahead while you do this. And it can make the process a little quicker. So these x's are going to cancel out. The negative 3y equals negative 3. Alright, and this I can solve for y very easily, dividing by negative 3. And y is 1. Remember, I still have to take this number and solve for x. So I plug it into whichever equation is easier. The first one here might be a little bit easier. So I'll use 2x plus 1 for y equals 11. So 2x is 10 after subtracting 1. And then x is 5. Remember to always write your answer for system of equations as an ordered pair. So 5, comma 1. Alright, again, so that one we multiplied both equations just to show you how to do it. But again, it's going to make the most sense to always try and do the least amount of work possible. So multiply one equation instead of both when you have the option. And one thing you can see if it's already set up with a positive and a negative, then use that variable to eliminate. So here I have positive, negative, so all I have to do would be to multiply this top equation by 3, and I'll have it set up to where I have 3y and negative 3y that will cancel out. Don't need to make any changes to the bottom equation. And we'll go ahead and add those together. So 3x and 2x comes to 5x. These will cancel out. 30 minus 20 is 10. Divide, x is 2. Still need to go through and plug in whichever equation is easier. Here, the top equation is definitely easier. We have x plus y is 10, so that means 2 plus y is 10, so y would have to be 8. And final answer again, we're going to write as an ordered pair. So 2, comma 8. So now we've learned 3 different ways for solving systems. Alright, so we solve systems. We can solve by graphing. We can solve by substitution. And third, we can solve by elimination. So if there's one way you're the most comfortable with, you can go through the process of doing all your problems that way. There's going to be situations where each of the 3 ways has an advantage. It'll be a little bit quicker, and we'll go through that tomorrow. But know that now we've learned all 3 different ways that we're going to learn for solving system equations. So there's 4 problems there at the bottom. So practice doing these ones by elimination, just so you get the feel for it, see if maybe this is the way you want to go about it. If you want to search for any other resources or videos online, just search for solving systems of equations by substitution. elimination for this video.